Hello, my name is Dmitry, and we continue to work on our e-commerce website that will go into production. In this part, we will set up GitHub repo, we will initialize monorepository, we will add backend service, and we will work on a security a little bit, and finally we merge our first pull request. In any bigger company, you will most likely work with Jira, but for our project, that's fine to use Trello. That's a very efficient way to track your progress and manage your project by slicing it into smaller features and implement it one by one. Let's move initialize backend into a progress. We don't have any repository yet. Let's create new GitHub repository that called Okina. Other settings we will keep it just like that, and we will create repository. We will need this section when we can push an existing repository from the command line. I'll create new Nx project through WebStorm plugin. Let's select Nx workspace and name it Okina. Let's copy this command and hit create. Let's select NestJS as a backend framework, application name just API, and we're not gonna connect our project to distributed caching at the moment. After it's done, we can migrate Nx to the latest version. Let's hit npm install. As you remember, I just created the project through WebStorm plugin, but you can simply use this command: npx create Nx workspace, and it will do the same. Just provide workspace name, select NestJS, call it API, and here just press no. So we can do both, use plugins or just CLI. Now we can push our project into a Git repository. Select branch and push it. It asks me to enter passphrase, but it may require you to follow other authentication steps. Voila, that's pushed already. Let's add more unversion files. After init commit and push. Let's push it into our remote. Now we can absorb our files, and here we got our initial commit in place. Let's create new feature branch. Name it feature init backend. And why do we do it like that? We're gonna use something that called Git Flow. We have, for example, main branch, but we also should have develop branch, where we gonna do our actual development. Those arrows represents two features that developed in parallel. Later on, when we're happy with our state of developing branch, we can sync it with main branch via release branch and merge it into a main branch. This is how we do hotfix. We do branch out of main branch and merge it back to a main branch and sync it with development later on. If it somehow looks complicated, It is a little bit, but that will dramatically improve your development experience in bigger teams, and it will allow you to do perfect release management. So that's actually required for any medium to big size applications. We will start creating our actual backend service with initializing Prisma and connect it to database. Let's create a specific library for Prisma. This is gonna be JS library. Nx provides lots of different types of libraries, generators, but in this case we will gonna use JS library with the name data access db, which is database, into a directory API with compiler as we see. This library gonna be buildable and with tag scope API. Only libraries with tag scope API gonna be allowed to import each other. We don't need any tests for this library. This one already created under library API data access db. Why is that called data access? Because that's an Nx recommendation. Here we see that Nx recommend to use small number of types, such as below 4 types of libraries. Feature libraries for a feature slice, like we have a user feature, and all logic should sit inside the same feature users folders. UI libraries for some UI dump components. Data access libraries. Those libraries have an access for the data. For example, for a backend application, data access library could access S3 bucket, that file storage, or database, or some other file storages or databases. For front-end application, this could be API calls or store managers and something like that. For utility libraries, you can put a bunch of trash in there, but be mindful what you put inside your utility libraries. Let's continue with adding Prisma. Let's run npm install and install some packages, Prisma and envcmd. Also, we will need one more package called Prisma client, and it's not gonna be a development package. Let's add some basic Prisma schema and delete unneeded file. So as you see, that's pretty basic schema with a link to an env variable. We will supply it via envcmd package. We have basic user model with ID, email, and name and password with some comments above it. Don't think about it at the moment. We'll discuss those later. Let's add some actual Prisma model and service. NestJS documents, brilliant place to start. Let's search for a Prisma service and just let's copy it over. New file, prisma.service.js, paste it in here, and voila. TypeScript doesn't like those like that, so you should supply it via a different type of syntax. And now TypeScript happy. Let's also create Prisma model, prisma.model.js, and paste it in here. Let's import those. Prisma model and Prisma service. Now we are almost there. Let's now link Prisma schema into our package JSON file. here's the place for Prisma. And now let's see if it works. Formatting messed up a little bit, so you can type Prisma format. And now it's formatted correctly, and it means everything works. I mean, link works. Let's also create environment variables, so Prisma can pull it from OkinoDB URL. Let's create new file .local.env and paste OkinoDB URL inside. Here's gonna be Postgres with the username and password, localhost where it's gonna be served, and database we're gonna be connected at. But how we're gonna actually connect to our database? We should run our database environment. There's gonna be Docker file with a Docker compose, which contain only database for our use case with the correct port, name, and password. Let's add a command to our package.json that will help us to spin up our Docker containers. So this is gonna be Docker compose, Okino environment, dev Docker compose, no recreate, remove orphans. Let's run it. And we're already there. To actually start to work with the Prisma, we should migrate our data into actual database. Let's add migration command, which gonna be npx envcmd, which gonna pick up local env file and run npx prisma migrate dev. Oops, I already have something inside, but I don't care about it. Yes, all data will be lost. We have a new migration, and before we deploy something, we're gonna store everything inside one migration called init. So, isn't it beautiful? Prisma understands schema and generates some tables based on that. So we have something inside our database already. It's empty tables. Let's actually add one more command. Prisma actually provides the way how you observe your database. You can use any third party, but at the moment we find with Prisma Studio. As you see, now we have all models. We have only user model, and it's pretty empty. So it actually means we are successfully connected to our database, but it's empty. Let's add user resolvers and some mutations into it so we can create some users. We're gonna be using GraphQL, so we should install a bunch of packages. We're gonna use NestJS mercurius GraphQL with a fastify, and we need class transformer and class-validator to validate our input. Why we're using fastify? Because in NextJS docs it says performance fastify. Sounds great to me, I don't know. So we are able to just drop in fastify and it works. So I'm actually happy with express performance, but it's so easy to replace it with fastify. So I don't see any reasons why I do not use fastify. Let's copy it over from docs, import every package that we need. We don't need API prefix because we're gonna be using GraphQL, and we're actually gonna say GraphQL because that's the name of a playground. Now we find and dandy. Let's continue to import our packages and stuff to run our GraphQL server. Let's actually uninstall Express because we're not gonna use it. And let's go to that docs with a mercurius integration and copy GraphQL model from here. Let's go to app model. We don't need controllers and app service anymore. Let's remove unneeded files and imports. Also, let's import GraphQL model with correct types and drivers. And that's pretty much it for importing GraphQL. Now we can start to add in our resolvers. But before do that, let's actually show GraphQL model where auto-generated schema gonna be located at. We have run import. That one is fine. And now we can add some resolvers. Our resolvers gonna be stored at feature library named feature user with inside directory API, compiler SVC, buildable and tag scope API. Let's generate that. This one will need jest. And let's open a folder with generated stuff. Let's remove unneeded files. Let's install. And now we can actually generate our resolvers. Nx also have some generators for NestJS resolvers. Let's use nest resource, which gonna generate stuff inside project named API feature user. Name of a project you can check inside project JSON, that's API feature user that we're using here. Inside directory lib with type of graphql-code-first. It means that we're writing code that will generate GraphQL schema. We want crud, that means create, read, update, delete with name user. So inside user we got a bunch of stuff, but I don't want it to be inside user, I want it inside lib. Let's delete user folder. What we got there? We got everything actually. We have create user, find all users, find one, update user, remove user. I want to rename it like users and user. Now it's time to connect it with Prisma. Inside user model, imports, Prisma model. Inside service, we now can refer constructor private read only Prisma service. Now to find all users, we need this Prisma user. Not imported Prisma service user dot find many. Now when we will call users, it will find all, find many inside our database and return the result. But here we got some problem. Let's actually provide some types there. And as you see, it's unhappy with types. But why is that? Because user actually generated by Nest resource generator, and it doesn't know anything about our users. It have some just dummy example field. We should write our actual user fields. And you can do it by yourself, but I want to use some shortcut. And I'll show you how to speed up this. To use shortcut that I'm talking about, we need to generate one more library named generate DB types. It's not gonna be tested. and add one more package, Prisma NestJS GraphQL. That's some specific generator for Prisma that's gonna generate our types based on our schema. Let's go into a schema file and add generator settings. There are a bunch of settings, but you don't actually have to understand that. And if you want to understand that, go ahead and read Prisma NestJS GraphQL documentation. And we have some bunch of decorators and validators on top of our schema. So generator will pick up those comments and inject validator statements on top of our fields. Let's see what I mean by that. Let's run Prisma generate and check our new library. And as you can see, it's full of types. Let's actually find user. And as you can see, it's already typed and ready to be used by GraphQL. All fields, nullable, true, name, email, not nullable, password already hidden for a user that's gonna request our users. And let's fix our user resolver. We don't need DTOs and entities anymore because we have those in here in our generated types. Let's remove it from here and import generated ones. For create user input, we have create one user arguments. Create user arguments, remove unneeded stuff. For user, fix that. And that as well. We'll also find unique user args. So we can find it using ID or email or any unique fields. But we have only 2 unique fields. For update user, we have update one user args. And so on. So now we can work on our user service to actually make requests. And those gonna be the same. Create one user args. Now we're gonna do this Prisma user create one user args. And what are create one user args actually? Inside create one user args, we have data that covered with GraphQL types and validate nested statement. So inside user create input, we have ID, which is optional and nullable for GraphQL. We have email covered with validator, name covered with validators. That's gonna be string, max 100 characters, minimum 3 characters, and password with some other validators. Isn't it beautiful that we got everything out of the box? I know it actually bad practice to couple your database models so close to your presentational models. But for most of the resolvers, I guess, we will have the same models. And if we're not, we can write validators and input types ourselves. Let's finish fixing our resolver. So now we're ready to actually test if it works. Let's start development server. Now we got an error, and what it says? It says query root must be provided. It means in app model we don't actually provide any resolvers. So let's import user model and see if it's happy now. Yes, it is. Let's head into our playground. Let's get some users. We don't have any. Let's try to create user. And we successfully created user with my name. Let's try to test our validation and create user with invalid email. We created user with invalid email. Why is that? I know the answer. But first of all, let's fix that import. We not exporting user model. That's why it's not imported correctly. Let's fix that with the correct imports. Yep, now ESLint is happy. And let's fix our validation. We need some validation providers. Let's get imports in place and provide validation provider. Let's try to create user with invalid email now. As you see, bad request exception. So now if I'll supply some messed up input, it's gonna be bad request exception. Let's fix that. Let's fix input. Password, testadin, test1, test.com, create user, and now it's created successfully. Let's try to create user with the same email. As you see, we got error from Prisma. As you see, we now completely covered with validation, and we're able to create our users, get our users, and it was so easy to implement that. I almost didn't write any types at all, any GraphQL types at all, just schema, and everything else I just generated. And that's it for this video. I'll see you at the next one. Hold on, do you think I'll let you go like that? What's about security, guys? What's about security? Why everybody all the time forget about the security? Let's head into a Nest documentation, and that's why it's important, I guess, to use frameworks, because it have everything in place. Look, section named security. That have authentication, authorization, encryption. What about encryption, guys? I didn't encrypt my password. No. We're not gonna do it like that. We have to encrypt our data. Let's first of all install bcrypt. What's up with that? Oh yeah, that's a legit error. Let's install bcrypt. Also, let's install bcrypt types and copy the way how it hashes the password. Let's get into a resolver and create user. All business logic should be inside user service. So here, let's just paste it just like that. Made it async import bcrypt like that. Now we should hash our password. Let's get data from our arguments. Now get data password, remove unneeded, that hashed password, and put it inside here. data password, hashed password, and that's it. Why is not happy with password? Oh yeah, that's my issue. It's gonna be data and like that. So now we easily just hashed our password, and it's important to do that. Also, what's about helmet? Let's express default, and with Fastify we should install Fastify helmet. What is Fastify helmet? It's just a bunch of security handlers that important to have in place. Let's copy it over our main.ts. Application register helmet. Let's copy the way it's imports. Nice, we already have our helmet in place, but one more thing. Content security policy should be false, but for development only. I'll have to do here. Should be turned on in production. We'll manage that when we will implement the way we communicate with our environment variables. What about CORS? Cross-origin resource sharing. So we don't want to share anything cross-origin. We have one origin, our website, and it's gonna be shared only for our website. Let's enable CORS. And you can read about it more in the NestJS docs. CSRF protection, that's a very important one. You can and you should read about it, but I'm not gonna implement it right now because I don't know how I'm gonna supply tokens to my NestJS application. And well, when I will implement any features that require CSRF protection, I will for sure implement that. Rate limiting. It's not that easy to implement with Fastify, unfortunately, and I guess I'm gonna rate limit my production server through some DigitalOcean load balancer or something like that on behalf of DigitalOcean. And now, finally, we can push it into our branch. Let's select all our files and add it. Let's write some comment about what we did. Added backend, GraphQL, and users feature. Commit and push. Let's check warnings and packages on warnings. We don't care about it. Defined but never used. Not major one. We'll automatically remove those unused variables later on. And migration. I'm happy with that. Let's push it. Now inside our repo, we can create our first pull request. Let's just copy it over, create pull request. Here we can add some automation on every pull request. We will do it later on. And we can read what files and how those files modified. And that's a very important process for a bigger company. For this project, I am by my own, so I'm happy with what I did. And I can merge it with squash and merge. Voila, everything inside. I'll update README with every command that I used, so you can use it on your projects. And that's it for this part, and I'll see you at the next one. Don't forget to like and subscribe. Bye.